Look here, today let's discuss about the channel from the block diagram. Yesterday we have discussed about is communication. This is the communication block diagram. Sorry, it's in reverse direction. See, this is the communication block diagram. So from this block diagram today we are going to learn about this channel. Actually, today let's go deep dive into the information about the channel, complete information about the channel. Actually, what channel is? It is the medium which transfers the information in the form of message from transmitter to the receiver. So generally there are two types of channels. One is point to point channel and the other is broadcast channel. In coming to point channel, we have one transmitter and one receiver. Example for this point to point transmission or point to point channel is wire lines, microwave links, and my optical fiber. Okay, broadcast channel is that we have very wide range of transferring the messages. In broadcast channel, the range of transferring the messages is very high. So in that we have one transmitter and we are having multiple receivers. Okay, example for this broadcast channel is satellite communication, and this is the general classification of the channel. Okay, and based on the communication, the channels are divided into four types. See, they are mobile radio communication channel and telephone communication channel. Third one is optical fiber communication channel, and the fourth one is satellite communication channel. So let's go deep dive into the information regarding this communicating channels. Okay, first let's discuss about the mobile radio communication channel. It is basically nowadays this channel is basically used in the telecommunication industry due to the because of the mobility of the signals. Mobility is nothing but the movement. Okay, telecommunication, so basically the factors which are responsible for the um for obtaining this phenomenon is scattering and diffraction or diffraction of the signals. Okay, as per my knowledge, scattering is nothing but gathering the signals at the transmitter end, and diffraction is nothing but the dispersing of the signals at the receiver end. These are the two factors which are responsible for the working of the mobile radio communication channel. Okay, the best example for this mobile radio communication channels are mobile towers. First one is mobile towers, and radio stations. Okay, these are responsible. Basically the working of this mobile radio communication channel is it will be taking the signals from the transmitter and it will disperse the signals at the receiver end. So basically I want to give you a clear clarity about this mobile radio communication channel is nothing but calling. Okay, calling through our mobile phone. Let's say that I have called a person from X place to the other person in the Y place. I am the person who is calling and transferring the information in the form of voice, which is mixed with the noise over my end. Because of the mobile we are using it is having one transmitter and the receiver in the mobile, so it will convert this non-electrical signal, which is my voice, and it will mm, purify, it will process my voice, which is mixed with the noise from my end into the electrical signal, and it will transfer into the voice again without the noise. That means it will deliver the um, clear voice, clear information without noise on the other end. That means to the person on at the position Y. So basically, this is the clear clarity, and I have given you that scattering and dispersing of the signals. That means I'm from as I am the transmitter. As I am the transmitter, all the mixed signals are gathered from at my end, and a clear signal is dispersed at the Y end. So this is mobile radio communication channel. Next we have, see, this is the diagram of mobile radio communication channel. Basically, this is the tower and this is the mobile. Okay, so as I am the transmitter, my signals are going to the tower which is near to me, and from there it is dispersing. The signals are getting dispersed to the person who is on the Y end. So the examples are radio station and mobile signal towers. Okay, next we have telephone communication channel. Okay, basically in both these channels, see, in both the ends. Okay, in mobile radio communication channel, this is point to point communication, because I am having only one transmitter and one receiver. I am the person who is at the X end is the transmitter, and the person who is at the Y end is the receiver. Okay, next coming to the telephone communication channel, telephone or mobile communication. Here also the medium is telephone or the mobile. Okay, in this channel it may be radio station as well, and here only telephone, that is only mobile. Okay, here based on the temporary purpose, we are using this channel for end to end communication. X and Y are the ends, end to end communication, like from my end to the person on the other side. This is for only temporary purpose. Okay, yeah, and this communication channels involves all the types of frequencies in the voice. Okay, human speech, that is from 300 to 3100 hertz. Basically this is on and off communication channel. Okay, yeah, in the previous channel I have given you the example of calling the person, right? Okay, I am taking the same example here. Okay, let's take the phenomenon. I have called the person who is on, let's take, I'm the person who is at the X end, and I'm the transmitter, and the receiver is on the Y end. So I'm calling him. As I'm calling him, the message is transferred through the mobile phone. He get the notification by ringing the mobile. So as he lifts the call, the message is transferred, and when I decline or the other person declines the call, the transferring of the message stops. That is on and off. Okay, here the best example for this telephone communication channel is switched circuit. Let's take basically the best example from our life is fan and switch. Okay, when we on the switch, the working of the fan starts, and when we switch off the switch, the working of the fan stops. In the same way, when the other person on the other side lifts the call, the transferring of the messages starts, and when either me or the other person declines the call, the transferring of the messages stops. So in technical words, the example is switched circuit. It is, so basically let's um, uh, basically we need to know that telephone communication channel is nothing but it is used for the temporary purpose, as it is helpful for on and off communication only. Okay, next we have um, optical fiber communication. Here also we this channel, telephone communication channel, also comes under point to point channel. Okay, because see, as we have given as we have given examples for point to point communication are wire wire lines, next microwave links and optical fiber, right? Wire lines, see, for this both telephone and mobile radio communications, the signals are transferred from the towers by wire lines. Okay, so these two communication channels falls under point to point communication. Okay, next we have optical fiber communication. This is clear cut example of point to point communication. Okay, so let's see the block diagram, how the information is transferred in optical fiber channel, and in after that we discuss clearly how basically the internal function of the optical fiber works. Okay, first let's see the block diagram. We have information source and we have the destination. Here we have another is electrical transmit, and next we have here down is electrical stage, next optical source, and other we have photodiode. Let's um, yeah let's compare this block diagram with yesterday's block diagram. Please check out my previous video for the block diagram of the basic block diagram of the communication channel. In the yesterday's block diagram also we have information source, that also we have information source. Here we have electrical transmit, there we have transducer, here we have optical source, there we have transmitter, and here we have photodiode, there we have channel. Okay, here the channel in this block diagram is optical fiber. Okay, did you getting my point? In the place of optical fiber, in the place of channel from the yesterday's block diagram, we are having here optical fiber. In that place we are having photodiode, photo detector. So in the place of, basically while working practically we can use photo detector here. Okay, and in that receiver, we in the place of receiver from the yesterday's block diagram we are having electrical stage here, and at the place of destination we are having destination here. I'm showing you it clearly again. Yesterday's block diagram, just look at here, source of information, input transducer, there we have what we have, sorry, yep, yes, here we have electrical transmit, sorry, here we have input transducer, here we have transmitter, there we have optical source, in the place of channel we have photo detector. Next we have receiver. At receiver and at the place of receiver, sorry, in the place of receiver we are having photo detector, and in the place of, sorry, 1 2 3 4 5 6, yeah, in the place of channel, sorry, in the place of channel we are having optical fiber which is linked with photo detector. Okay, and next in the place of receiver we are having electrical stage in that block diagram, and here we are having destination as usual. So basically in this block diagram also we told that channel is nothing but the source which transfers, sorry, it is the medium which transfers the information from source to destination. Okay, this is source to destination, it is transferring the message. So basically as I told, information source. Okay, information source. Let me take my voice as the source of information which is mixed with different types of unwanted signals. Basically my speech is also the is also a signal which is mixed with different types of unwanted signals. It is passed through electrical yeah, it is passed with electrical transmit. Here this electrical transmitter converts it into the electrical signal which removes the unwanted signals. After that these electrical signals are transferred with into the optical source which basically converts these electrical signals into the light signals. Okay, here I have given this is, yeah, see, light signal I have given here, and this light signal from the optical source is transferred through the optical fiber into photo detector. Okay, photo detector, and from this photo detector, okay, from this photo detector the signal is transferred to the electrical stage again, which basically converts this light signal into the electric signal again without noise. Okay, without noise, and this electrical signal is converted to the normal voice without unwanted signals, and it is transferred to the destination. Okay, so basically the examples of optical source is LED or laser, and on the other end in the place of photo detector we can use photodiode. Okay, so this is basic block diagram or the working of the optical fiber, basically how the information is transferred from source to destination by using the optical fiber. Now let's discuss how the internal work happens in the optical fiber. Optical fiber, this is internal working of the optical fiber. Let's take that this is the optical fiber which consists of two layers. One is core, the inside the inside part of the optical fiber is known as core, and the outside part of the optical fiber is known as cladding. Nu is the refractive index. Basically we need to find the refractive index of the optical fiber. Refractive index can be calculated. Nu is equal to C by V. Okay, C by V. So let's take the refractive index of the core of the refractive index of the core of the optical fiber is nu1, and the refractive index of the cladding, that means the outer part of the fiber, is nu2. So basically nu1 is great, and c is the velocity or speed of light in vacuum by speed of the light in vacuum, and v is the velocity of the light in medium. Okay, so basically we will be having nu1 refractive index. So let's give me a second. Just give me a second. Just look into this block diagram. We have yeah. So we are having nu 1 is greater than nu 2. Refractive index of core is greater than the refractive index of the cladding, and as we learned in our earlier not earlier in our pre-primary like class 12 or something, that in that classes we have learned about the term called total internal reflection. So let's discuss how this total internal reflection has happened. Okay, so I'm taking two mediums which are separated by the surface. Okay, so this is the rarer medium and this is the denser medium. I am transferring a signal, okay, at angle theta 1. As I am, this is, let's take, this is the surface and this is the normal. As I am moving the signal away from the normal and closer to the surface with an angle theta 1, the rays or the signal passes into the rarer medium from denser medium with an angle theta 2, which moves very close to the surface. Okay, see, as the signal moves from denser medium, the angle formed by the signal in rarer medium is more. Okay, here theta 2 is greater than theta 1. Okay, sorry, from as we move the signal from denser medium to rarer medium, the angle formed in the denser medium is less than the angle formed in the rarer medium. That means the angle formed in the rarer medium is greater than the angle formed in the denser medium and vice versa. Okay, so as we what I told is, as we move the signal at a angle QC, that is critical angle, at critical angle, as critical angle gets interacted with surface, the angle theta 1 moves away from the normal. Okay, at an angle QC, the refracted wave, the passing away wave or the signal gets interacted with the surface. So basically the angle at which the refracted wave or the refracted signal in the rarer medium interacts with the surface, that angle is known as critical angle. Okay, as so basically as critical angle interacted with the surface, the angle theta 1 moves away from the normal. So it basically moves away from the normal. So as we are passing the wave from denser medium, right? So from denser medium, if the refracted wave or the refracted signal also comes into the same medium in which the say in which the signal is passed, that means q1 is equal to q2. If the passing angle and the refracted angle are in the same medium, then at that point we get total internal reflection. Okay, so this is the total internal reflection. At this stage, the transferring of the signal happens. Okay, so basically what are the advantages of using this optical fiber? Are this is large bandwidth, that it is having large bandwidth, that means the signal can travel into very large distance, that is 2 into 10 power 13 hertz. Okay, so this is the bandwidth. Okay, lightweight and negligible transmission loss. Okay, so basically the signal is lost very rare, like small amount of the signal is lost, that is 0.2 decibels per kilometer. Next, it is flexible, no electrical shocks were happened, and immune to electromagnetic interference. So basically it is mostly used for electromagnetic interference. This is optical fiber communication. Next we have satellite communication. Okay, as we people are very familiar with this satellite communication channel. So basically in the communication, satellite is used as the channel. Okay, that means we are having one transmitting end on the earth and the receiving end on the earth. We are passing the signals into the sky, where the satellite stations were developed or placed. So as we here we pass the radio frequency waves. So as we pass the radio frequency waves from earth at the satellite station, the signal is getting amplified, and the frequency of the signals which so basically we are passing the radio frequency waves with unwanted signals, right? So that unwanted signals will be getting removed at the satellite station, and we are getting the clear radio frequency wave to the receiving station here. Okay, so basically the basic height from the earth to the satellite today we are working on with is 22,300 miles. Okay, so these are geostationary orbits. That means it takes 24 hours for one rotation. Okay, as for one rotation, basically it is used for national and international communication. Okay, so these are the four and this satellite communication comes into broadcast channel. That means from satellite we are getting, let's let's connect it to the our day-to-day life. In today's life we are getting many informations from satellite. That means many stations were um, uh, developed here on earth to receive the signal from the satellite. Okay, so this basically comes under broadcasting channel. And the other three, mobile radio communication channel, telephone channel, and optical fiber communication channel, where comes under point to point channel. So just look into the two videos so that you will be getting the clear idea about the communication, how basically communication happens, and how basically the channels work. Okay, thank you.